Good day everyone. In this video we are going to learn about direct and inverse variation. What is direct and inverse variation? So the general formula for direct variation is y varies directly as we have x. So meaning it is y equal to kx, where k is called the constant variation and k will not be equal to 0. So always look for the hint there. So in the problem, it will state that direct or inverse variation. So therefore, if it is direct, you will have now as y equals to kx. Okay, let's try some example. For example, here, if y varies directly as x and y equals to 24 and x equal to 3, find the constant variation and find y when x is equals to 2. First thing you will do is find that we have the constant variation. So we can write that one as y equal to kx. So this is our general equation for we have direct variation. Given that y is 24, so y is 24 equal to, we have k times x is equals to 3. So therefore, our k now is equals to, we have 8. After finding the k, you will have now to solve for x equals to 2. Find y when x equals to 2. So we have k. So what you're going to do is just only substitute that 1. So therefore, you will have y equal to kx, where k is equals to 8. And then we're looking for, we have find y when x is equals to 2. So therefore, y is equals to 16. So as what I've said, always remember that if the problem will state direct variation, so therefore you will have now as y equals to kx. So another method is using proportion. So in proportion, you can have now as this one, y sub 1 over x sub 1 equal to y sub 2 over x sub 2, where you are not going to find the k or the constant variable or the constant value. So you can use also this one if the problem is just looking for x and y, we have unknown variables. Okay, so let's try some of the problems. So for example, if y varies directly as x and y equal to 6 when x is equal to 5. So therefore, here you have y equal to 6, which is this one is our y sub 1, and then this one will be our x sub 1. Then find y when x is equals to 15. So you are looking for y sub 2. Okay, when x is equals to 15, which is this one is our x sub 2. So you can have now, so here we will have y1 over x1 equal to y sub 2 over, we have x sub 2. And then using proportion method, you're just only doing cross multiplication. So you can have now 6, we have times 15. So we get 90, and then y times 5, we get 5y, which is equals to y equals to 18. The other way, if you're looking for, we have k, you can have this one as well, right? Y is equals to kx. We have our y is 6 and our x is 5. So therefore, you will have k, or the constant, is equal to 6 over 5. And then after that, you're going to have now to solve for here, going back, find y when x is 15. So therefore, you will have now as y equals to kx, where k is 6 over 5 and x is equals to 15, and we will get the same result. The result will be equal to positive 18. Okay, so try to practice more about problems so that you can have the idea how to solve for the x and y unknown, or looking for the unknown variables. So from here, y varies directly. So here again, you can see that y varies directly as x. So how did we get 13.5? So x sub 1, we have 8. Y sub 1 is equals to, we have 9. And then x sub 2 is equals to, we have 12. We are looking for y y sub 2. So you're going to do that one. You cross multiply again. So therefore you can get as 13.5. So what does the graph of a direct variation look like? So because this one is y varies directly as x, so therefore it will create a linear we have graph, or linear we have diagram, okay? And then it will intercept at we have 0. So let's try to solve this problem. So according to Hooke's law, the force required to stretch a spring x units beyond its natural length varies directly. So from there, you can already we have conclude that this one is a direct variation. Why? Because we have here the guide or the clue that we will have here. It says that the natural length varies directly as x. So therefore, how will we know that this one is y and this one is x? So the first we have variable here given the force required to stretch a spring. So therefore, y equal to the spring which is x. So we can have now the force will be our y. So a force of 30 pounds stretches a certain, we have spring 5 inches. So when you're going to create, okay, when you're going to put a force of 30 pounds, the spring will stretch 5 inches. The question is, find how far the spring is stretched by a 50-pound weight. What if we are going to put 50 pounds? How much is the, or how long, okay, the spring will stretch? Again, the force required to stretch a spring x units beyond its natural length varies directly as x, right? So you are going to apply 30, we have pounds, and then it will stretch us, we have the spring into 5 inches. The question is, what if we were going to put 50 pounds? What is the length now of the spring? Or how far the spring will stretch? So you're looking for, we have the x. So therefore we will have force over x1, force 2 over x2. So therefore the length of the spring now, after substituting the values of force and x, it will stretch us as 8 and 1/3 we have length. Okay, got it? Now try this one to solve by your own. So you can pause the video, then after that try to solve by your own so that you can practice. Okay, so it says that use Hooke's law. Hooke's law is for direct variation, to find how many pounds of force are needed to stretch a spring 15 inches if it takes 18 pounds to stretch it 13.5 inches. So now you're looking for y, right? Because it says here, when you're going to use 18 pounds, it will stretch as 13.5. So how many pounds you need to put in, okay? How many pounds of force you are going to use so that it will stretch 15 inches. Okay, so therefore you will just go for, we have the proportion method, and then you can check your answers. The answer must be 20 pounds. Now let's go to direct variation. Y varies inversely as x if k is not equal to 0, such that x, y, okay, x and y is equal to k, or it can be y equals to k over x. So either of the two, so you can have xy equals to k or y equals to kx. It says that y varies inversely. Inverse, right? We have to go for the inverse. We have sine. So therefore, you will have y equals to k over x. So the difference between the two of them, y is equals to kx for direct, and then y equals to k over x for inverse. The general form for proportion, the other one is we have y1 over x1, y2 over x2. But for inverse, you will have x1 over y2, x2 over y1. Okay, so let's try some example. Find y when x is equals to 15. If y varies inversely as x and x equals to 10 when y equals to, we have 12. So when you're going to look for k, so you will have now xy equals to k. So therefore that we have x and y is 10 and 12. So you have 120. And then you're looking for find y when x is equals to 15. So therefore you will have 15y because x is 15 there. So therefore 15 times y equals to 120 I mean, which is will give us y equals to 120 over, we have 15, that will give us equal to 8. Okay, so therefore try to get the k first and then you can solve for the other value which you're looking for, find the other y. When ratio and proportion the same, so you will have x1 is 15, y2 is 12, x2 is 10, and then you're looking for y sub 2, we get now equals to 8. So either way, which one you are going to use. But in the problem, if the problem asks find the constant value first, so you're looking for the constant value first before you're going to solve for the next we have problem. Here, find x when y is equals to 27. If y varies inversely as x and x equals to 9 when y is equals to 45. So try to pause the video again and then try to solve by yourself. So the answer there will give us, we have equal to 15. Okay, so try to practice more to solve, we have familiarized with the, we have given formulas. Okay, let's try some application. The pressure P of a compressed gas is inversely proportional to its volume V. So therefore here you can see pressure is inversely proportional to the volume. So therefore we can create already the formula there is pressure is equals to y and V is equals to x. So therefore we can have now as pressure equals to K over the volume. A pressure of 40 pounds per square inch is created by 600 cubic inches of certain gas. So find the pressure when the gas is compressed to 200 cubic inches. Okay, so therefore you're looking for, find the pressure, you're looking for y. So therefore you will have now as here x sub 1 over y2 equals to x sub 2 over y2. So you're looking for how many pounds you're going to insert, right? So therefore you can create now as equal to, we have 120 pounds. Okay, so go back here. So because you're going to a pressure of 40 pounds, it will create 600. What about if you will go for, we have find the pressure when the gas is compressed to 200 cubic. Okay, so therefore you will have 120 pounds. Okay, so that you can create, we have 600. Okay, next. From here, a pressure of 20 pounds per inch squared is exerted by 400 inches cubic of a certain gas. So you're looking for here, use Boyle's law to find the pressure. So how many pounds again, right? So that, okay, so you are going to find the pressure of the gas when it is compressed to a volume of 100 inches cubed. So therefore, the answer there will be given as 80 pounds. Okay, the answer will be 80 pounds. How did you get, we have 80, so you have 200 times 400 divide by, we have 100, so that we will get 80, we have pounds. Okay, so for example here, h varies directly as the square of L and inversely as the square root of M. When h is 10, L is equals to 4 and M is equals to, we have 64. Find the equation connecting h, L, and M. And also find h when L is 12 and M is equals to 256. So let's try to solve this one. So again, it says that h we have varies directly as the square of L. Okay, so therefore this one is a combined, we have problem of an direct, and inverse. So we have now as h varies directly as the square of L. So we will have L squared. And inversely, we have as the square root of M. So we have inversely as the square root of, we have M, and then times the value of K. So this one will be our equation. Now when H is equals to 10, so we are looking for K. So 10 equal to, okay, 10 equal to, L is 4, so therefore that is 4 squared, all over by the square root of 64. Okay, so we have M is 64. That is equals to K. So how much is that one? So we will have now as, we will get as 80 divided by 16. So therefore our K is equal to, we have 5. Next question. Find H when L is 12. So we have H is equal to, we are looking for H. The next problem. H is equal to, we have L is 12. So therefore that is 12 squared over 256. We have 256 for M. And then the K is equals to, we have, or the K, we'll just write it by 5. So how much is that? So try to compute so that you can get that one. So therefore you will have square root of 256 is equals to 16. So 144 divided by 16, and then times, we have 5. So therefore you will get as equals to 45. Okay, so that will be the solution for this problem. Okay, last problem. Let's try to solve with this equation. So we have P varies jointly with Q and R. So if it is jointly, so this one is P equal to Q and R. So we therefore Q times R times we have K. Okay, so the word there is jointly. Therefore, if you can see this one, if it is jointly, so therefore we are going to combine, we have the variables. So when P is equals to 98 equals to, we have 2 times 7 equals, or times K. So how much we get here? So we have K is equals to 98 divided by 14. So how much is that? So we will get now K equal to 7. Next, find, we have P now. So we are looking for P equals to 15 for Q and times 8 for R and times 7 for, we have the K. So therefore you will have now as 15 times 8 times, we have 7. And therefore you will get now the value of P is equals to 840. So again, if it is joint, you are just going to combine all the, we have equation. If it is, we have Y. So this one is the mathematical symbol for variation. We have varies directly to Kx. So this one is direct. And then the inverse is Y. We have inversely, we have, or varies inversely to K over X. This one will be the inverse. Okay. So therefore, you have we have different formulas, which is the Y. Okay, so varies jointly to X and Z times we have K. So this one is for jointly. Okay, so you have three different, we have formulas that you are going to remember. We have the direct, inverse, and jointly we have variations. Okay, so that's all for our lesson discussion for this video. Thank you so much.